Good evening, everyone. Welcome to my next video. That is, in previous video we were discussing about the pharmacokinetic model. That is compartment model. There were two. I explained that there are three pharmacokinetic models are there by which we can determine the drug concentration present in the body, like compartment model, perfusion or physiologic model, and non-compartment model. We already discussed about the compartment models in the previous video. Now we will discuss about the next two models. Actually, the compartment model itself is a very detailed model. That's why I made it in a single video. So the next video, today's video, will comprise as of the pharmacokinetic model only, the second model and third model. First model to check for the first pharmacokinetic model, which is compartment model, has been covered in earlier video. Now the second model is perfusion or physiologic model. So perfusion, generally known as blood flow, and the pharmacokinetic model depends upon the blood flow and the physiology. Physiology mainly the organs, physiological organs. Depending upon these two both, the drug concentration will be determined in case of this model, that is perfusion or physiologic model. Depending upon the blood flow, there are organs which are known as rapid equilibrating organs and slow equilibrating organs. Rapid equilibrating organs, where the equilibrium will be rapid when the organs which having higher blood flow, mainly the vital organs, will have rapid equilibration. So those organs consider the rapid equilibrating organs, and there are organs which have less blood flow, they consider the slow equilibrating organs. So generally arteries carries blood, that is mainly oxygenated blood, to different organs, like first of all to heart, and it will be pumped to all the organs, either rapid equilibrating organs or slow equilibrating organs. From these organs, the deoxygenated blood will be removed through veins. So, while arteries carrying oxygenated blood to the different organs, the drug also will be pumped to the different organs or distributed to the different organs, and veins remove the drug which has been entered to these different organs. That has been explained with the help of this perfusion or physiologic model. So blood flow is responsible for distribution of drugs, as well as the organs responsible for distribution, by which we can determine the drug concentration in different organs, as been explained by this model. That is, mainly blood flow and the physiological organs are responsible for the movement of drug inside the body, is explained by this model. Now, the next model is non-compartment model. As name indicates, non-compartment model. Non-compartment means it has no compartments. I guess we have discussed in the earlier video itself compartment, non-compartment model also. Non-compartment model means there is no compartments. It is not considered to be any compartment. There is no compartments. Assumptions are there in case of this non-compartment model, and this is based on statistics. That is, it is based on the statistical moment theory. So here we generally determine MRT, which is mean residence time. So mean residence time of drug is determined. What is this mean residence time? The average time the drug to be reside in the body, which is analogous to half-life. That is, it is equivalent to half-life of the drug, can be determined as AUMC upon AUC. So MRT, which is nothing but mean residence time. So in non-compartment model, mean residence time will be determined using this statistical moment theory. So what is mean residence time? The average time for the drug to reside in the body, which is analogous to T half, that is half-life. So MRT can be calculated as the ratio of AUMC upon AUC. Now what is AUC and AUMC? AUC is also known as, it is the area under zero moment curve, is AUC. whereas AUMC is area under first moment curve. So generally in statistics we use different moments to the power. So C to the power, C into T to the power n. So this n, exponential n, is known as the moment. If it is 0, then that is 0 moment curve. If it is 1, then that is first moment curve. So when C into T to the power 0, T to the power 0 is 1. So C into 1 is C. So when you plot the graph between time and concentration, you get a curve, and that curve is known as area under the curve. So the area which covers under this curve is AUC. Whereas first moment curve means C into T to the power 1, which is C into T. So you are plotting in y-axis C into T and in x-axis T. So you will get another graph, and the area covering under that is known as AUMC. So dividing AUMC by AUC will yield the mean residence time of any drug. Like this we can calculate the mean residence time. Now, how to calculate this area? How will you calculate the area under this curve or area under the first moment curve? Any curve you have, any curve like in IV injection, you will get a curve like this. So, area under this curve. This is the curve for extravascular system, and this is the curve for intravenous infusion. So, what is the area which is under that curve is generally determined to determine the extent of absorption. How much extensively the drug has been absorbed. कितना ज़्यादा drug absorb हो रखा है, उसको determine करने के लिए हम क्या determine करेंगे? AUC. AUC is used to determine the extent of absorption. How much the drug has been absorbed. So how to determine? एक curve के नीचे कितने, अब IV infusion में देते हैं तो maximum 100% होगा, उसके बाद time के हिसाब से drug concentration decrease होगा. Whereas IV infusion, that is through drips में चढ़ाते हैं ड्रग को, इनिशियली 0 होगा, धीरे धीरे इंक्रीज होते जाएगा, उसके बाद भी हम इन्फ्यूज कर रहे हैं तो स्टेडी स्टेट अचीव हो जाएगा, वहां पे आपको कांस्टेंट रेट पे ड्रग इंक्रीज होते जाता है. ये इन्फ्यूजन टाइम. जहां पे हम दिखा रहे हैं, दिस इज फॉर एक्स्ट्रावैस्कुलर रूट लाइक ओरल रूट, टॉपिकल रूट, ऑक्यूलर रूट, नेजल रूट, which are given outside the blood. blood के बाहर देते हैं, उसको extravascular route बोलते हैं. तो कर्व इस तरीके से आएगा बेल शेप में. तो जो भी एरिया उसके नीचे आ रहा है उसको कैलकुलेट करते हैं. किस लिए कैलकुलेट करते हैं? टू डिटरमाइन द एक्सटेंट ऑफ अब्जॉर्प्शन विच इज AUC. कैसे डिटरमाइन करेंगे? सो AUC और AUMC कैन बी डिटरमाइंड बाय डिफरेंट मेथड्स. One is square count method. So you plot graph में plot कर लो. So graph में ऐसे squares होता है, कितने number of squares have to be counted, और उस square को suitable units में convert करेंगे तो you can determine the AUC. Then there is another method which is known as cut and weigh method. So in cut and weigh method you have to make a graph again in graph paper, then you have to cut the curve and then you have to weigh, and the plotting area जो plot किए हैं उसका भी हम कट करके वे करेंगे, फिर suitable units यूज करके जो फॉर्मूला अप्लाई करेंगे तो उसी से भी AUC निकलेगा. सो अनदर मेथड इज बाय इंटीग्रेशन मेथड. इंटीग्रेशन मेथड व्हाई वी आर यूजिंग, क्यों AUC डिटरमाइन करने के लिए इंटीग्रेशन मेथड यूज करते हैं? बिकॉज ये जो एरिया जो होता है इट इज द इंटीग्रेटेड एरिया. इंटीग्रेटेड मतलब सम, मतलब addition of these areas when it is plotted between C and T. So integration method में integration of C into dt from 0 to infinity, this will give you the AUC. integration of concentration with respect to time हम integrate करते हैं from 0 time to infinite time, that is up to some time, उसको क्या कहते हैं? AUC कहते हैं. So इसी तरीके से इंटीग्रेट करेंगे पूरे कंसंट्रेशन को with respect to 0 to infinity time के हिसाब से, then also you can get the AUC. And lastly we have one method to determine the AUC is by trapezoidal rule, applying trapezoidal rule or trapezoidal method. What does it mean trapezoidal method? मतलब trapezoid का मतलब क्या होता है? It is the four sided shape. trapezoid वो होता है जिसमें चार साइड होता है, like square is also having four sides, rectangle is also having four sides. क्या डिफरेंस होता है इसमें? आपको जो स्क्वायर है तो ऑल साइड्स इक्वल होगा, रेक्टेंगल है तो दो साइड इक्वल होगा, दो साइड्स इक्वल होगा, बट आपका ट्रेपेजॉइड में ऐसा जरूरत नहीं है, चारों साइड अनइक्वल हो सकता है, बट ओनली थिंग इज दैट टू साइड्स either of any two sides must be parallel with each other. चारों साइड में कोई दो साइड है पैरेलली चलना है, जैसे रेल पटरी, जैसे रेलवे ट्रैक, लाइक दे शुड गो पैरेलली. दैट इज द मेन रूल ऑफ दिस ट्रेपेजॉइड. ट्रेपेजॉइड का कैलकुलेट करने का फॉर्मूला एरिया जो है हाफ इंटू बी इंटू एच. सो व्हाई वी आर यूजिंग ट्रेपेजॉइड? बिकॉज से फॉर एग्जांपल ये जीरो टाइम है, जीरो टाइम पे इतने कंसंट्रेशन, टाइम ये 1 आ रहा है, ये 2 आ रहा है, ये 3 आ रहा है, 4 आ रहा है, 5 आ रहा है, देन इफ यू आर कंसीडरिंग 6 आर, सो 1 आर का यहाँ पे मिलेगा, सो 2 आर का यहाँ पे मिल रहा है, 3 आर का यहाँ पीक मिल गया, 4 आर यहाँ पे और 5 आर यहाँ पे. नाउ यू जस्ट डिवाइड ऑल द, इन सबको डिवाइड करेंगे, इसी तरीके से डिवाइड करते हैं तो यू हैव डिफरेंट ट्रेपेजॉइड्स. देखो ये दोनों पैरेलल है, ये दोनों पैरेलल है, ये दोनों पैरेलल, ये दोनों पैरेलल, ये दोनों पैरेलल. इन सब को डिफरेंट ट्रेपेजॉइड्स में हम डिवाइड कर लिया. ट्रेपेजॉइड 1, ट्रेपेजॉइड 2, 3, 4, 5 and 6. So we have 6 trapezoids. So individual trapezoid का एरिया निकाल के सबको सम करेंगे. That is AUC can be calculated as summation of half into B क्या होता है? It is base and height concentration होता है. So क्या करते हैं? Half into base के लिए time into height के लिए concentration is the term C into T. इन सबको सम करते हैं तो you will get the area of a ट्रेपेजॉइड. ये पूरे ट्रेपेजॉइड का कंप्लीटली आपको इंडिविजुअल ट्रेपेजॉइड में कन्वर्ट डिवाइड करके फिर ऐड कर दिया तो यू विल गेट द एरिया अंडर दिस कर्व. दिस इज अनदर मेथड फॉर डिटरमाइनिंग AUC. ये AUC AUMC इसी मेथड्स में कोई मेथड यूज करके डिटरमाइन करके इफ यू डिवाइड बोथ AUMC by AUC you will get MRT. This method is known as non-compartmental analysis. क्या एडवांटेज है नॉन कंपार्टमेंटल कंपेयर टू कंपार्टमेंट? कंपार्टमेंट में बहुत सारे इंटीग्रेशन, डिफरेंशिएशन, कॉम्प्लेक्स इक्वेशन, मैथमेटिकल इक्वेशन सॉल्यूशंस करना पड़ता है, बट हियर ओनली सिंपल इक्वेशंस आर यूज्ड टू डिटरमाइन. बट द एडवांटेज ऑफ कंपार्टमेंट मॉडल, यू गेट ऑल द डिटेल्ड इंफॉर्मेशन. हर फार्माकोकाइनेटिक पैरामीटर्स को डिटेइलली डिटरमाइन करने यूज हो सकता है, बट नॉन कंपार्टमेंट मॉडल में उतने डिटेल्ड रिजल्ट्स नहीं मिलेगा. So this is all about the pharmacokinetic models. So there are 3 pharmacokinetic models are there: compartment model, perfusion or physiologic model, and non-compartment. Compartment means body is divided into different compartments. Perfusion physiological model मतलब organ और blood flow के हिसाब से हम मॉडल को डिवाइड करते हैं. Then non-compartment में there is no compartment. Statistical moment theory AUC AMC यूज करके हम डिटरमाइन करते हैं drug concentration, then that is known as non-compartmental analysis. Now we will move on to the main pharmacokinetic models individually: one compartment model, multi-compartment model, multiple dosing in further videos. So we'll meet in next video, that is to one compartment model in detail. Thank you.